Hello and welcome to another video tutorial. In this tutorial we're going to go through the metals and acids assessment, where the way that I'll format it, same as last time, I'll go through it as if I'm going through and doing the test myself. I'll explain answers as I go along to try and explain the correct answers, as well as obviously showing on screen what they are and talking through them. What I want you to be able to do is have access to your own Google form. Correct your answers as you go along on the Google Doc, so that if, for example, you've got question 1, you've made a mistake on one of these, you would put number 1, A equals, and then the correct answer. And you only need to put the corrections onto the Google Doc. So without further ado, we'll make a start going through this, and as I say, you should be able to access your Google form, have the Google Doc open, and you can pause and rewind the video and take it however which way you want. It should make it quite easy to get through, and if there are any questions, by all means message me and I will help. So number 1, here we've got 1A, 1B, 1C. All that we have to do is label the diagram using the words below. Eloise adds a piece of metal to some acid in a test tube. She uses the apparatus below. So what we should put here: A is the test tube, B is your acid, and C is the metal just in the bottom of the test tube. 2. Tick the correct box or boxes for each state symbol to give their meaning. That was a little bit misleading to some extent, but without giving too much away with the question, you essentially only have one answer per state symbol. So where we've got S is for solid, L there is for liquid, G is for gas, and AQ, sometimes meant for aqueous solution, essentially meaning it's a solution in water, or we could just put here solution as that tick box there. Number 3, brick and pottery are examples of ceramic materials. Tick the boxes next to 3 properties that are typical of ceramics. So go through the list and we'll try and work out which ones of these are a property of typical ceramics. High melting point is, think about how a lot of your ceramics are produced, and you may think of a kiln as a way of trying to process some of those ceramics. Bendy, they are not. They're very, very rigid and perhaps to some extent even brittle. Insulator of electricity, they are, and they do not react with water, which is why you can essentially use ceramics for, let's say, a vase or a pot that you might fill water in, and they are not shiny. Write down the 4 missing words in the order that they should appear in the paragraph. Sophie is testing a gas. She collects some of the gas. She puts a something splint in the gas. So we've got hydrogen, lighted or pop. So it's going to be a lighted or lit splint. The flame goes out. There is a squeaky. It's either hydrogen or pop. We'll go with pop. This is the hydrogen test, and therefore it shows the gas is hydrogen. 5A, Roisin has samples of 3 different materials. She wants to compare how vigorously the metals react with hydrochloric acid. Name one piece of apparatus that Roisin could put the acid in. The answer that I expect from most of you is, oh dear, is test tube. However, if you put beaker or boiling tube, I would accept those answers as well. But I say most of you did choose test tube or beaker. Give 2 things that Roisin must do to compare the reactions fairly. So there's a choice of things here. There are 2 things, but the ones essentially within the mark scheme of making sure that you can do this as a fair test is to have the same amount, or you may have chosen there the word volume, which is perhaps even better, of acid. You could say the same size, or again volume, of metal pieces, and another option that you could have had there is the same temperature for the acid. Now, thinking of safety precautions that Roisin must take, there's a wide variation of things that you could have come up with. The two main ones that I wanted you to come up with here were to wear safety goggles or eye protection. Now this is essentially the two big ones that the mark scheme wanted you to come up with. And not to touch the acid. You may have answered, and there are a couple of answers on the lines of simply saying wearing goggles or wearing gloves, and those were fine as answers. All of the safety lab and safety in the lab and procedures that we tend to follow day to day within the lab, all of those great. But these are the two key ones that the mark scheme wanted you to bring out, and that's why I've put those on the screen. Magnesium reacts with dilute hydrochloric acid. Compare the products. The products of the reaction are magnesium chloride and hydrogen. Complete the word equation for the reaction to fill in the blanks A and B. So just working through here, we've got magnesium reacts with dilute hydrochloric acid. So A is our hydrochloric acid, and B, it says the products of the reaction are magnesium chloride and hydrogen. So let me just highlight that, magnesium chloride and hydrogen. We've got magnesium chloride here, so that means that B must be hydrogen. Name two products formed when zinc reacts with dilute hydrochloric acid. And essentially what we're looking at here is, if we just take, for example, the answers to the previous question, where we've got magnesium chloride and hydrogen, we can apply that here where we've got, instead of magnesium, we've got zinc, but we've still got hydrochloric acid. So if magnesium and hydrochloric acid gave us magnesium chloride, which is our salt, then zinc and hydrochloric acid should give us zinc chloride. Well, here we've got zinc chloride plus something. Well, magnesium with the hydrochloric acid gave us magnesium chloride. We've covered that bit, that's our salt, plus the hydrogen gas. So here, just by replacing our metal, we should also get the hydrogen gas, or we'll just put it as hydrogen. Name one metal that does not react with dilute hydrochloric acid. And the four that the mark scheme kind of points out here are gold, silver, platinum, or copper. And it's essentially any metals that are really quite unreactive. And in terms of the answers, all of you did really well on that 6C. Magnesium also reacts with dilute sulfuric acid. Name the two products formed in this reaction. So this time, instead of changing the metal, we've now changed the acid. So we should still get similar pattern here in terms of our answers, because what we're looking for here in 6D is magnesium plus sulfuric acid. What will be the salt formed from that? Well, we end up with magnesium sulfate. But we still have another product, which is going to be, in fact, our gas, and this gas is going to be hydrogen. So on to 7AI. Small pieces of iron burn in air to make iron oxide. Name the gas in the air that the iron reacts with. Just go back to this compound name there, iron oxide. Think about where the oxide bit comes from, and it is oxygen. Okay, so it's a good way of just working out what it might be. Write out a word equation for the burning reaction of iron. So we've got here, iron burns in air to make iron oxide. So we'll use that previous answer to say iron plus oxygen. And what will that become? It says here that small piece of iron burn in air to make iron oxide. So our product here is going to be iron oxide. So there's a mark for putting oxygen, and there's a mark there filling in those dots, which is iron oxide. Here is part of the reactivity series given to you: magnesium, zinc, iron, lead, copper, silver, gold, platinum. Predict whether or not name one metal that burns more vigorously in air than iron. So out of this list here, just working with this list, zinc or magnesium are more reactive than iron. They're higher up in the reactivity series, so you could put here magnesium or zinc. Predict whether or not platinum burns in air. Give a reason for your answer. Now this is all part of question 7. So we're still just kind of working our way down, and we may have to use related parts, for example, this reactivity series. So platinum there being right at the bottom of our reactivity series that's given to us. Well, what you've got to do is then work out whether or not platinum will burn in air, and pretty much all of you got this right and said no, it will not burn in air. Give a reason for your answer. This is justifying it. It's very unreactive. You could say it's at the bottom of the reactivity series, or you could make a comparison and say it's less reactive than gold, which doesn't react with air. So if gold doesn't do it, anything lower or less reactive, that won't do it either. 7b part 3, give the position of the mystery metal in the reactivity series compared to magnesium and zinc. So it says here Milo adds small samples of magnesium, zinc and a mystery metal to a big trough of water. His observations are in the table. So you've got magnesium, tiny bubbles, zinc, no change, mystery metal, bubbles form rapidly. So if zinc had no change when it was dropped in to the water, mystery metal, which does appear to show bubbles, is going to be more reactive than the zinc. But we've got tiny bubbles for magnesium, and we've got rapidly forming bubbles for the mystery metal. Therefore, the conclusion we can come up with is that it is higher in terms of reactivity than magnesium and zinc. Number 8. This is your first 6-mark question. Quite a lot of text to go through, so just read through it. A teacher has samples of 3 different metals. He does not know which metals they are, but he knows that they are above zinc in the reactivity series. Describe an experiment that will show which of the metals is most reactive and which is least reactive. In your answer, state what the teacher should do, how he can make sure his experiment is fair, and what the results will show. You can imagine this as me in the lab if you want to. The list below shows part of the reactivity series, so this time we've got a slightly different set of metals: potassium, sodium, lithium, calcium, magnesium, zinc, iron and copper, and we're told that they are above zinc. Now, what's the significance of the question telling us that they're above zinc? The significance is that they will react, for example, in water. So, you get marks for how well your answer is written, so it has to follow a logical order. It's what's known as sometimes a QWC, quality of written communication answer. However, you can also do this in very clear, logical, succinct points. So the way that I'll do this is just go through it line by line and try and break down and give a kind of example answer. So what could you do with the metals? So you could fill similar sized test tubes with equal volumes of water and at the same temperature. Why is that important? It's essentially for a fair test. It's making sure that your experiment is fair and you've controlled those variables. And that actually hits 2 of the marks here. 2 of the marks here are for how are you going to make sure that the test is fair. What will you then do to it? Well, you'll add similar size pieces of metals into each individual test tube, and what you'll then do, in fact we could even be more specific here. We could say fill 3 similar sized and 3 similar sized pieces of each metal into each individual test tube, so 1 metal per test tube. And what will you then do? You will, or he being potentially me, he should observe each reaction. The more vigorous the reaction, the more reactive the metal is, and the opposite is true. The less vigorous the reaction, the less reactive the metal is. And by that we're looking at examples such as how quickly do bubbles form, how many bubbles form, what happens, is there lots of gas being given off, for example. Okay, so lots of different things to think about here. Okay, so on to our next one. In fact, let me, just before we go on to our next one, just break this down. So you get 2 marks here for your 2 different statements of trying to keep it a fair test. A mark here for your the start of your method, a mark here for saying that you observe it and maybe note down your observations, a mark there for saying how to know which one's more reactive, and a mark for saying which one's less reactive. And that's how you make up your 6 marks. You will need to refer to the information below for the parts of question 9. It's about displacement reactions, so it's already told you it's about displacement reactions. You'll need to use the reactivity series below. Magnesium, zinc, iron, lead, copper and silver. Predict which 2 pairs of substances below can react, give reasons for your decisions. It's a 6-mark question. Now because it says which 2 pairs, you only need to work out which 2, but it's 6 marks. So split your 6 marks equally and you've got to get essentially 3 marks per pair. And that means that you'll get a mark for identifying the pair, and then you've got to build on it by trying to justify why you've chosen it, and that's worth 2 marks each. So let's go with this. We've got magnesium and iron chloride, lead and copper, copper and iron, silver and copper. It's a displacement reaction. A more reactive metal displaces a less reactive metal from its solution. So magnesium can displace the iron. Lead can displace the copper. This is B. C. The copper can't displace the iron. It's less reactive than the iron. The silver, right at the bottom, can't displace the copper. So our answers are going to be A, and they're going to be B. But now we have to justify. That's only 2 marks. If you just put A and B, that's 2 marks, 1 mark each for identifying it. So now we'll say here, well, magnesium is more reactive than iron. That's a mark. So it will displace the iron. And you've explained that you understand what a displacement reaction is. You've justified how you know it applies to this pair, and you've already identified the pair. That's your 3 marks for A. So let's have a look at the same format here. Lead is more reactive than copper. So lead displaces copper from its compound. And if you wanted to, we could even, we could add that one in here, the iron from its compound, just if you want that fullness to your answer. And that's it, that's your 6 marker. Aluminium reacts with iron oxide in the thermite reaction. It's one that we looked at as we were going through this module. So it reacts with iron oxide. Write a word equation for the reaction. Let's follow the format from before, where we'll essentially put 2 things together and we'll have our arrow similar to what we had here in 7AII. Okay, so aluminium plus iron oxide. What's that going to go to? And here you have to think back to the thermite reaction. Or you can think back to here. Iron being fairly sort of lower down, aluminium not shown in this table, but it is more reactive than the iron. So it's going to be a displacement reaction, and what we end up with is iron plus aluminium oxide. Predict one metal that does not react with iron oxide. essentially any that's less reactive than iron. If it's less reactive, then there won't be this displacement reaction. So from the list, you could put lead, copper, silver, and the common answers that a lot of you went for were copper, silver, gold, and platinum. Predict one metal that does react with iron oxide, where we're going to look at ones that are more reactive. For example, magnesium, zinc. There's essentially any that are more reactive than iron, and I guess we should put in this one here as well from that previous one, which is aluminium. Okay, so there ends our review and the video tutorial going through this assessment on metals and acids, and I hope that it was really useful, and I hope that you've used it to go and make your list of corrections as required on your Google Doc, and that you've gone through your Google form just to see how you did, what you did, and how to improve. And if you have any questions, please get in touch with me and send me a message.